Hey everybody, and welcome to a special solar eclipse edition of Mondays with Mike. I'm very excited to walk you through some kind of nerdy science stuff, but also some really interesting facts about solar eclipses and the upcoming Texas total solar eclipse. So we're going to go through 10 amazing facts, 10 things that you need to know about the solar eclipse. Now, before we get started, the first thing I want to just define really simply, what is the solar eclipse? It's very easy, really, when you look at the basics of it. You have the sun, you have the moon, you have the earth. And the moon passes between the earth and the sun and temporarily blocks our view of the sun. That's the basics of it, but it is a pretty rare event. We'll talk about why it's so rare. So this total solar eclipse will be visible across much of Texas, including especially to the west of San Antonio and Austin, especially areas just west of Austin. It'll also be visible from Dallas, Fort Worth, and those spots. In the Houston area, we're going to have about 90% of the sun covered, which is very cool. But totality, when it's completely covered, that's the magic. That's why people fly from across the world to see it, because if the sky is clear, you can actually see stars twinkling during the day. You can even sometimes see planets during the day. So that's an amazing thing. Now, if you miss seeing this one, or if it happens to be raining or cloudy or something like that, fact number one is that the next opportunity you're going to have to see a total solar eclipse anywhere near us. There's going to be one coming up in North America coming up on August the 23rd of 2044. But as far as basically close to Texas, you have to wait until August 12th, 2045. Yeah, that's a ways off. And it's going to move through Oklahoma, Arkansas, back over to Mississippi. So it's basically within a road trip's distance. But that's the next time it is going to be close to us. So that's fact number one. All right. Fact number two, and this one I love, and it is the question of why don't we see eclipses every month? Because doesn't the moon pass between the earth and the sun every single month? Well, yes, it does. And the reason we don't see eclipses every month is that the moon's orbit around the earth is actually tilted a little bit. So it doesn't go directly around the equator of the earth. It's tilted at about 5 degrees of angle. And so with that in mind, it actually is a pretty rare occurrence that with that tilted orbit, as the sun, I mean, remember that the earth is tilted, the moon is tilted, and we're all going around the sun. And so it's rare that in your area you see a total solar eclipse. In fact, they only really happen about every 20 years or so. So that is something that's very special, and it's even more rare that it will happen in Texas. That'll be visible in Texas. We have a lot of partial solar eclipses. They'll happen every few years. But a total solar eclipse is a big, big deal. Now, I think I'm going to insert here, I have my whiteboard here, and so let's go ahead and insert a little bit of an aside about the moon's orbit. All right, so let's talk about it. If the moon goes around the earth once every 29 days, once a month, why in the world don't we have a solar eclipse every month? Why is it so rare? Well, it comes down to this, and I'll do my best to draw it here on my whiteboard. Oh, come on here, whiteboard. All right, so here we go. I'm not an artist. Here is the Earth, okay? And the Earth is tilted like this. And here's our equator, okay? So, whoops. So, there's the Earth, okay? And then the Earth, let's say we go around our orbit, around the sun, like this. That's the orbit that we follow. Whoops. That's the orbit that we follow around the sun, or what you would call the plane of the orbit. Now, the thing is, the moon does not follow that same plane. the moon goes around like this. Okay? It's at an angle of about 5 degrees. Okay? 5-degree angle. So what that means is that the Earth goes around the sun like this, okay? But the moon goes around the Earth kind of like this at an angle. So it makes it much more rare, much more special, much harder to see the moon actually pass directly between our view of the sun because it's not moving over the same area every single month. All right, so you know how much I like to use my whiteboard, and I think it's something a lot of people don't think about. The fact that the moon just is its orbit around our planet is actually pretty complicated. All right, so as we'll talk about here with another aside on the whiteboard, why are these total solar eclipses so rare, and why is it that so few people can see it? I mean, if there is a total solar eclipse, why can't everybody see it? Why do we have to drive all over the country or fly all over the country to see it? Well, here's why. All right, so I think another great question is, why can't everybody see it? Yes, okay, so we've kind of done enough talking about why it's such a special thing to see and how amazing it's going to be and what a once-in-a-lifetime kind of opportunity it is. But why is it that we got to drive out to Fredericksburg to see this thing, or at least to Austin, or maybe drive up to Fort Worth to get a view of it? Why don't we have a total eclipse here in Houston? Why doesn't everybody just get a total solar eclipse? Well, let's take a look. It all has to do with the size of the moon and the size of the sun. So let's go ahead and draw, once again, our Earth. Whoops, I did that again. That is, of course, the Earth. And this is not to scale. Okay, if I drew this to scale, it would look really weird because I would have to put the moon way over there. Because, by the way, it's about 250,000 miles away. But we're just going to put it right here, okay? The moon is about 1/6 the size of the Earth. So comparatively, it's much smaller than the Earth is. The sun, obviously, is gigantic. And the sunlight, we think about the sunlight hitting us directly. But in reality, the sunlight looks like this, okay? The sunlight comes across like this. Okay, so it hits us there, it hits us there. That's where we all get our sunlight. Now, the reason that everybody doesn't see it is, imagine the Earth is this big, the moon is roughly that big. So it focuses the shadow onto a very small point. Okay, like this. Okay. Just this little spot is the only area that actually gets to see the eclipse, and that's called the umbra. B-R-A, the umbra. And it is the same root word as umbrella, and even like Rihanna said it, right? Under my umbrella. So anyway, that's the umbra. Now, there are areas here where you're partially under the umbra. So like there's what's called the penumbra. So we'll say this is partial. These are the partial areas, and then this is the total. Okay, so this will track its way across the, like this. This is a terrible drawing. What's happening here is like the total eclipse will be visible here, and only on this strip is where you'll be able to see the total eclipse. So this is the total. And if you don't live in that little strip, then you can't see it. So that's why it's such a special thing, and that's why Texas doesn't end up in this area very often. Because this is only, by the way, about 60 to 100 miles. wide. Wide. That's embarrassing. W-I-D-E. This area here is only about 60 to 100 miles wide. So we don't really end up in that little narrow strip very often. Now, if the moon were enormous, or let's say we switch places, if we are on the moon, then the Earth would eclipse the sun in a way more dramatic way. In fact, that's what would happen, from your point of view, during a lunar eclipse. So a lunar eclipse is when the Earth casts shadow on the moon. The view from the moon would be a solar eclipse for the moon. So if we ever colonize the moon, then it's going to be amazing to see. Let's go ahead and draw that. See if I can't mess this up, right? All right, so let's say we're living on the moon. There's the moon. And the sun is over there, and the Earth is here. Well, now all of a sudden, the Earth's shadow does this. And you see the sun completely blocked. But it doesn't look as, I don't know, I wouldn't think that it looks that, maybe it does look impressive. I don't know. I've never been to the moon. If you happen to go there, let me know. But this is what it would look like if you were on the moon, seeing the Earth covering the sun. Here. The next fact that I want to tell you, this is, by the way, this is on fact number 4, the question number 4, which is how often do they happen? There's actually a cycle that was apparently known to the ancients, and the cycle is about every 223 years. Now that doesn't mean that there's only a solar eclipse every 223 years, but there's a repeating pattern of total solar eclipses that are based on that time frame, and then sort of divided in there. We know that it happens, give or take about every 20 years or so. The thing is that even within that cycle of repetition, it's so rare, as I just showed you, that it's visible from your location because of how I explained about how the shadow cast on the Earth, or basically the area of the Earth where the sun is blocked by the moon, is only about 60 miles wide, maybe 100 miles wide. So if you're not in that strip of what would be considered totality, or that total solar eclipse, then you're out of luck. You get to see a partial solar eclipse, which is cool, but like I said, I mean, that total solar eclipse is the once-in-a-lifetime, basically, event that very few people are ever going to see. And in fact, people will hop on a plane and fly to Australia, or people from Australia will hop on a plane and fly to Texas just to experience that event. I mean, darkness in the middle of the day, being able to see stars in the middle of the day. Can you imagine to the ancients what in the world they thought was happening? I mean, a lot of these accounts, historical accounts of eclipses, go back about 3,000 years, maybe 4,000 years. Ancient China, they wrote about it, and it was as if an animal or a dragon were eating the sun. The ancient Egyptians, tracked these sort of things. The ancient Greeks, the ancient Romans. I mean, so many people tracked it and tried to understand what was happening. But really, it wasn't. We didn't really truly understand it until we started to get the models of the orbits around the sun that the planets take, and the orbits that the moon takes around the Earth, from people like Copernicus and Kepler, and then later on people like Sir Edmund Halley / Haley did a lot of work in that regard. So it's pretty cool. Now, one thing. Now, this is amazing. This is fact number 5. What is the corona? Now, no, we're not talking about the virus. We're not talking about the beer, because corona means crown. And the corona is this incredible, we don't want to call it an atmosphere, but it surrounds the sun. And it is this large area of extremely hot gas. We're talking about more than 1,000,000 degrees. The surface of the sun is about 10,000 degrees. It's about what's called 5,500 K in Kelvin. And but the corona could be 1,000,000. 1,000,000. In fact, I think 1 to 3 million degrees, the corona. And you can't see the corona under any ordinary circumstances. First of all, we don't look at the sun, but even if you were to look at the sun with welder's goggles or special glasses, you can't see the corona. But you can see it when the moon is completely covering the sun. And that's a very special thing to be able to see. This corona is between 150 and 450 times as hot as the surface of the sun. And what's interesting is, okay, so this is according to NASA, the exact mechanism by which the corona is heated is still the subject of some debate, but it likely has to do with episodic energy releases from the variabilities in the magnetic field of the sun. The outer edges of the sun's corona are constantly being transported away. In fact, it's part of the reason why we have this solar wind. I mean, there are particles that are constantly flying away from the sun at about 1,000,000 miles per hour, and they arrive to the Earth and they get steered by the Earth's magnetic field to the poles, and that's why we have the northern lights, you know, the aurora borealis and the southern lights and so forth. So there's a lot of mass that's constantly leaving the sun, and the corona is one visualization of that. But I would love to see it. And it would be pretty cool to see. And by the way, you won't be able to see it if you're using those eclipse glasses, which brings me to number 6. Why do they always warn you not to look at the eclipse? Okay, well, the simple answer is that exposing your eyes, and this, I'm not an optometrist or ophthalmologist, as you know, but exposing your eyes to the sun without proper eye protection during a solar eclipse can cause retinal burns. I don't know about you, but I don't want any retinal burns. That sounds terrible. It's known as solar retinopathy. The retina has no sensitivity to pain, so you won't know that you're damaging your retina. And since the effects of the retinal damage may not appear for hours, there's no warning that you've had an injury to your vision. The vision loss can be temporary or permanent and can cause you a lifetime of distorted vision or altered color vision. And it's all based on how long you look at the sun. Now, here's the deal. Once the sun is completely covered, once it reaches that moment of totality where it is completely covered by the moon, then you can briefly take off your eye protection and look at the sun. Now, don't take my word for it. Check with your eye doctor, check some online resources, but that is my understanding, is that once the sun is completely covered, you're no longer in danger of receiving the UV radiation, the ultraviolet radiation, the infrared radiation to damage your retina. But you have to make sure it is completely covered. Safety first. But at the same time, it's great to experience the amazingness of what happens when the sun is completely covered. Also, by the way, NASA says that children are at particular risk because more light is focused on the retina in young eyes than it is in older eyes, and so they are actually more susceptible. Plus, they have the rest of their life to deal with the consequences, right? So make sure that we don't look directly at the sun unless it's in complete totality, and even then, be very, very careful. All right, number 7. You may be wondering this, and I think it's very interesting to explain, and that is lunar eclipses. What's the difference between the solar and the lunar, and why don't we make as big of a deal about the lunar eclipse? Like, why don't people fly to Australia to see a lunar eclipse? Well, back to the whiteboard we go. All right, number 8. is one of my favorites, and it's a question that I don't know, maybe if you haven't thought about, and that is, does anything else pass between our view and the sun? Because we know that the moon will move across and block our view of the sun, but aren't there other things out there, other planets, other this and that? So the answer is yes. There are two other things that pass between the Earth and the sun. One is the planet Venus, which is our sister planet, and the other is the planet Mercury, which is a desolate sphere that is very close to the sun and is devoid of any atmosphere or really anything interesting. When it passes the sun, when they pass in front of the sun, it's called a transit. What's a transit? Well, it's like a baby eclipse. They're very cool. I don't want to talk too much about it because you will never get a chance to see one, but there are two other objects that are between the Earth and the sun, other than the moon. You have our sister planet Venus, and then you have Mercury. Mercury is not a place you would want to be. Neither is Venus. But Mercury has no atmosphere. It is just a rock, and it has it's bombarded constantly by the sun. At least one side is. So it's 700 degrees on the side that's facing the sun with relentless nonstop radiation, which would kill you instantly. Or you're on the other side, the shadow side of the sun, where it's like 200 degrees below zero, 300 degrees below zero, and you would also freeze to death instantly. When Mercury transits the sun, or passes between us and the sun, it looks like that. That's it. And you would never be able to see it unless you had special viewing equipment. That's going to happen in 2032. When Venus transits the sun, it kind of looks like that. And because Venus is larger and it's closer to us. So that I would like to see. Unfortunately, I won't live to see it because it's not happening again until after the year 2100. All right, moving on to number 9. Now, I thought about this, and I thought, hey, it's a great question. I want to share it with you because it, I think, is a pretty amazing fact about solar eclipses. And the question is, do other planets have solar eclipses? I mean, look, there's 7 other planets, 8 if you want to count little Pluto. And the question is, do they experience eclipses of the sun? And the answer is, I'll let you take your guess. Yes, the answer is yes, they do. Now, you wouldn't have any eclipses on Mercury because that's the closest one to the sun. Venus, if you were living on Venus, you would be able to very rarely see a transit of Mercury across the sun, but I wouldn't call that an eclipse. Mars, if you were on Mars, you would very, very, very rarely be able to see a transit of Earth across the sun. But there are 2 moons that orbit Mars. They're not real impressive moons, Phobos and Deimos. They're kind of like, they're captured asteroids. So they're kind of long and weird looking and everything. They're not like our beautiful spherical moon. And they can pass in front of the sun too, but they're too small to completely block the sun. On other planets, especially Jupiter. Now, Jupiter has almost 100 moons that we've found. I think over 90 moons that we know of. It has 4 giant ones. It has Ganymede, it has Io, it has Europa, and Callisto. And each one is like a planet-sized moon. They're very big as far as, comparison to Earth. And they will block the sun a bit in parts of Jupiter. In fact, there are some really cool pictures you can search up of shadows cast on Jupiter that were seen by some of our probes that we've sent out, Voyager and so forth, that we can take pictures of Jupiter and see shadows on Jupiter, and those shadows are solar eclipses. Pretty awesome, isn't it? And then the farther out you go, the thing is, like, farther out into the outer portions of the solar system, the sun is so small that it really wouldn't get blocked. I know Saturn has a very, very large moon called Titan, which is the largest moon of the solar system. Maybe that blocks the sun, but I would think that it would be extremely rare, and you wouldn't be able to see it through it's a gas giant planet anyway. But the answer is yes, you can see solar eclipses from other planets. All right, finally, I want to leave you with this. This is fact number 10, which is Bailey beads What in the world is that? Well, it's awesome. Now, you have to be right in that path of totality to see it, but basically, the moon is not a perf, 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 not a